So our next question is, let the equation ax square plus 2hxy plus by square equals 0 represents a pair of straight lines. Then the angle theta between the lines is given by cos theta is equals to mod a plus b by root of a minus b whole square plus 4h square. So here we have a pair of straight lines equation. Okay, we need to solve this and prove that the angle is cos theta is equal to this one. Okay, so let ax square plus 2hxy plus by square equals 0 represents lines b L1x plus m1y equal to 0, equation 1, and next is L2x plus m2y equal to 0, equation 2. Multiplying these two lines, L1x plus m1y into L2x plus m2y equals to this equation ax square plus 2hxy plus by square. Multiplication L1 L2 x square plus L1 m2 xy plus L2 m1 xy, and the last term is m1 m2 y square equals to the same ax square plus 2hxy plus by square. Here taking xy common, so it is L1 L2 x square plus L1 m2 plus L2 m1 into xy plus m1 m2 y square equal to the same ax square plus 2hxy plus by square. Here we'll compare the coefficient of x square, xy and y square with this equation. So the value of a will be L1 L2 and the value of 2h is this term. 2h is equal to L1 m2 plus L2 m1, and the value of b is equal to m1 m2. Okay, now theta be the angle. Let theta be the angle between the lines 1 and 2. Then here is the formula. If two lines are, the lines are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Then the formula of cos theta, then the cos theta angle between them is given by mod a1 a2 plus b1 b2 by root of a1 square plus b1 square into root of a2 square plus b2 square. Okay, it's still here only for this term. Okay, so this is the formula. So here we are having the lines L1x plus m1y equals 0 and L2x plus m2y equals 0, right? So we can write it as cos theta is equal to a1 a2 values, m1 m2 is b1 b2 values. So it is L1 L2 plus m1 m2 by root of L1 square plus m1 square into root of L2 square plus m2 square. Now multiplying the denominators and keeping the numerator as it is. So it is under root of L1 L2 square, L1 square into L2 square plus L1 square into m2 square plus the third term L2 square m1 square, and the last term is m1 square and m2 square. Right, now we have to add and subtract here in the denominator. In the denominator, add and subtract the term 2L1 L2 m1 m2. Okay, this term you need to add and subtract. So our equation will be cos theta equal to mod L1 L2 plus M1 M2 by under root of L1 square L2 square plus M1 square M2 square minus 2 L1 L2 M1 M2. Okay, I have arranged this M1 M2 in the first. Okay, plus L1 square M2 square plus L2 square M1 square plus 2 L1 L2 M1 M2. So we subtracted and added this term. Okay, so it is cos theta is equal to mod L1 L2 plus M1 M2 by root of, so this is whole term, we can write whole squares, right? Whole squares, so this will be a square plus b square minus 2ab, so we can write a minus b whole square, so it is L1 L2 minus M1 M2 whole square. Similarly, this is a plus b whole square term, so it is L1 M2 plus L2 M1 whole square. Now substituting the value of this all, L1 L2 value is a and M1 M2 value is b. By root, this is a and b, so it is a minus b whole square plus this value is of 2h, so it is 2h square. So this will be equal to mod a plus b by root of a minus b whole square plus 2 square is 4h square. So this is only we need to prove. So our next question is, show that the product of the perpendicular distances from the point alpha comma beta to the pair of straight lines ax square plus 2hxy plus by square equal to 0 is mod a alpha square plus 2h alpha beta plus b beta square by root of a minus b whole square plus 4h square, right? So here it is given as the product of the perpendicular distances. Okay, so you have to remember the formula of perpendicular distance from any point. Okay, first we will consider two straight lines, pair of lines. Okay, solution, let ax square plus 2hxy plus by square equal to 0 represents the lines B L1x plus M1y equals 0 equation 1 and L2x plus M2y equals 0 equation 2. Multiplication of these two lines will get the coefficient A, 2h and B. M2y equals to ax square plus 2hxy plus by square. So L1 L2 x square plus L1 M2 xy plus L2 M1 xy plus last is M1 M2 y square. Taking xy common, so it is L1 L2 x square plus L1 M2 plus L2 M1 whole square, sorry, into xy plus M1 M2 y square. So the value of A is L1 L2, 2h is L1 M2 plus L2 M1 and B is M1 M2, comparing with the coefficients. Okay, so now the question, in the question it is given perpendicular distance, right? So the length of perpendicular, this is the formula. Okay, the length of perpendicular distance from any point x1 comma y1 to any line ax1 plus b y1 plus c equal to 0 is given by the formula ax1 plus b y1 plus c by root of a square plus b square. Okay, this is the formula you need to remember. So line 1, so perpendicular distance from alpha beta to the first line, that is L1x plus M1y equal to 0, is mod L1x L1 alpha plus M1 beta by root L1 square plus M1 square. Okay. Similarly, perpendicular distances from alpha beta to the line 2, L2x plus M2y equal to 0 will be L2 alpha plus M2 beta by root of L2 square plus M2 square. In the question, it is given as the product of these two distances perpendicular. Okay, so we need to multiply this two product. Okay, in the question it is given as product, so we need to multiply the two lines. So it is mod L1 alpha plus M1 beta by root L1 square plus M1 square into the second line perpendicular distance, mod L2 alpha plus M2 beta by root L2 square plus M2 square. So now we need to multiply the numerators and also the denominators. So it will be L1 L2 alpha square plus L1 M2 alpha beta plus L2 M1 alpha beta plus M1 M2 beta square in the numerator multiplications. Similarly, in the denominator, root of L1 square L2 square plus L1 square M2 square plus L2 square M1 square plus M1 square M2 square. Okay, so now again we need to add and subtract. First I will write whole squares. Wait, so it is mod L1 L2 numerator same, alpha square plus, here taking alpha beta common, so it is L1 M2 plus L2 M1 into alpha beta plus M1 M2 beta square by root of L1 L2 whole square plus, writing this term first, so it is M1 M2 whole square plus L1 M2 square plus L2 M1 square. Now add and subtract 2 L1 L2 M1 M2 in the denominator. So it is mod L1 L2 alpha square plus L1 M2 plus L2 M1 alpha beta plus M1 M2 beta square by root of L1 L2 whole square plus M1 M2 whole square. Here subtracting 2 L1 L2 M1 M2 plus L1 M2 whole square plus L2 M1 whole square plus 2 L1 L2 M1 M2. Okay, so numerator as it is alpha square plus L1 M2 plus L2 M1 B alpha beta plus M1 M2 beta square by, here this is the formula, a square plus b square minus 2ab, so it will be a minus b whole square root of L1 L2 minus M1 M2 whole square plus, and this is a square plus b square plus 2ab, so it is a plus b whole square, so it is L1 M2 plus L2 M1 whole square. Now substituting the values of this is a value, right? L1 L2 is a value, so it is mod of a alpha square plus this is the value of 2h alpha beta, and this is the value of b beta square by root of, this is a minus b value, a minus b whole square, and this is 2h value, so it is 2h square So this can be written as mod A alpha square plus 2h alpha beta plus b beta square by root of a minus b whole square plus 2 squares is 4, 4h square. So this is we need to prove.